Welcome to the world of quantum computing and its potential to revolutionize artificial intelligence. Quantum computing has the potential to solve problems that are currently beyond the reach of classical computers, and it has the potential to revolutionize fields such as machine learning and artificial intelligence. So, what is quantum computing, and how does it work? In classical computing, information is processed using bits, which can represent either a 0 or a 1. Quantum computers, on the other hand, use quantum bits, or qubits, which can represent both a 0 and a 1 at the same time. This property, known as superposition, allows quantum computers to perform certain calculations much faster than classical computers. That all sounds complicated. In simple terms, classical computing is like using a regular car to get from one place to another. You input a destination into the GPS and the car follows a predetermined route to get there. This is similar to how classical computers process and analyze data. They use bits, which can only represent a 1 or a 0 at any given time, to perform calculations and solve problems. Quantum computing is like using a helicopter to get from one place to another. Instead of following a predetermined route, the helicopter can analyze multiple possibilities and find the most efficient way to get to the destination. This is similar to how quantum computers work. They use quantum bits or qubits, which can represent both 1 and 0 simultaneously, to process and analyze data. Quantum computers also have the ability to use another quantum property known as entanglement to perform calculations even faster. Entanglement is a hard thing to wrap your head around. Here is another analogy. Imagine you have two friends, Alice and Bob, who are each given a coin. Alice flips her coin and it comes up heads, while Bob flips his coin and it comes up tails. Now, imagine that Alice and Bob are each given a choice. They can either keep their own coin, or they can trade coins with each other. If Alice and Bob are not quantumly entangled, then they will each make their decision based on their own coin. Alice may decide to keep her heads coin, while Bob may decide to trade his tails coin for Alice's heads coin. In this case, they are not influenced by each other's choices. Now, imagine that Alice and Bob are quantumly entangled. This means that their coins are connected in such a way that they can exist in multiple states simultaneously. This is called superposition. For example, if Alice's coin is in a state of superposition, it could be both heads and tails at the same time. Similarly, if Bob's coin is in a state of superposition, it could also be both heads and tails at the same time. In this case, Alice and Bob are unable to make independent decisions about their coins, because their choices are influenced by the state of the other coin. For example, if Alice decides to keep her heads coin, Bob's coin will automatically become tails, and vice versa. This is the essence of quantum entanglement. The state of one particle can affect the state of another, even if the particles are separated by large distances. So, in summary, quantum entanglement is like two people being connected in such a way that the choices they make are influenced by each other, even if they are not in the same location. Superposition is the phenomenon that allows particles to exist in multiple states simultaneously, which is what enables quantum entanglement to occur. So, how does all of this relate to artificial intelligence? Well, machine learning algorithms rely on processing vast amounts of data in order to learn and make predictions. Quantum computers have the potential to process this data much faster than classical computers, which means that they could potentially enhance the performance of machine learning algorithms and improve the accuracy of AI systems. Google has been working on quantum computing for several years and has made significant progress in the field. In 2019, the company announced that its quantum computer had achieved quantum supremacy, meaning it had performed a calculation that would be impossible for a classical computer to complete. This quantum computer, like all the others, are extremely sensitive to their environment, and must be kept in very specific conditions in order to function properly. Quantum computers must be kept at extremely low temperatures in order to function properly. This is because the quantum states of the particles used in quantum computers are easily disrupted by heat, which can cause errors in the calculations performed by the computer. As a result, quantum computers are usually cooled to temperatures near absolute zero, about -273 degrees Celsius. Even the presence of a human can alter the quantum state. I doubt we will have a quantum computer in our pocket physically in the near future. However, we will very soon be outsourcing its power from a quantum server, much like we do already with a traditional server. The big companies like Apple will need a server like this to revolutionize with the market. AI assistants will be a trend. Starting from right now with ChatGPT, people will feel left behind or feel like they are missing out on an opportunity. That fear and curiosity will force this technology into the mainstream and fund the revolutionization of the market rapidly. Quantum computers won't be part of this next step in the revolution. However, humans always want an upgrade. Going from a traditional server to a quantum server would be that upgrade. With this configuration of the quantum computer being complex, requiring certain conditions to be maintained, and feeding amazing computing capabilities to the devices we hold in our hands. Again, I go back to how we as humans always recreate ourselves within computers but enhance the capabilities. What if we have created a duplication, in the form of electrical transmission of a conscious feeder? It's all theory, but Imagine if we were the devices, and we are feeding consciousness from elsewhere, because the configuration and conditions couldn't be held in our bodies. Like the quantum computer. All speculation but food for thought. In addition, quantum computers could potentially be used to solve problems that are currently beyond the reach of classical computers, such as optimizing complex systems or finding patterns in large data sets. This could lead to the development of new AI applications and technologies that we can't even imagine yet. Maybe this is the key to unlocking the partnership of the five senses and making a truly conscious AI. Quantum computing is a rapidly evolving field, and it's hard to predict exactly what the future will hold. But one thing is certain, quantum computers have the potential to revolutionize the field of artificial intelligence and bring about a new era of technological advancement.